In this problem, we have to see what fraction of this rectangle is shaded. So these parts over here are considered to be shaded. So one way that we can solve this is by using coordinate geometry, which basically means taking this figure and moving it to the coordinate axis and treating these lines as actual lines in the coordinate axis and these points as points in the coordinate axis as well. So for instance, first of all, let's just suppose that the rectangle's width is twice as big as its height. So therefore, we can basically say that this length is 2. Remember, the problem doesn't give us any hints on what these lengths are, so we can just make them up ourselves. So we can say that the rectangle is 2 times as big for its width than its height. So if the width is 2, the height should be 1, and we can just assume this. And so when we translate this to the coordinate axis, we can pretend that this point is 0, 0, 0, 0. This point is 2, 0 because this length is 2, 2, 0. And then we can do it for all corners. This is 0, 1, and this is 2, 1. Right there. And now, how does this help? Well, from this, what we can see is that there are 3 lines in there are 3 lines inside the rectangle. This line, and this line. And we can find the equations for all 3 of these lines, since we're considering this rectangle to be in the coordinate axis. Let's start with this diagonal line right here. We know that the y-intercept is going to be 0, 1, so it's going to be y equals something times x plus 1. And so the slope will be, well, let's see, it goes down 1 to the right 2, so that equation will be y equals negative 1/2 x plus 1. And that is the equation for this diagonal line right here. It goes down 1 to the right 2, and then it has a y-intercept of 1. And we can do that for these two also. For this one, if you use the same logic, the y-intercept here would be in between 0 and 1, so 1/2. And the slope would be, well, up 1/2 to the right 2, so it would be y equals 1/4 x plus 1/2. Because since it's going 1/2 and then 2, then technically it will go 1/4 and then 1, basically. Because 1/2 divided by 2 is equal to 1/4, as you can see. And finally, so we found this one and this one. We can now find the equation for this. Now this one's a little bit tricky because we can't find the y-intercept. We can't see what the y-intercept is exactly yet, but we do know that, let's see, we can find the slope. So if this is, again, since these two sides are similar, this is going to be 1, 0, this point right here. 1, 0. And let's see, it goes up 1 to the right 1. So this actually has a slope of slope of 1. So it's y equals x. And let's see, what would its y-intercept be? Well, if we continue this line downwards, it will be -1, -1, and it will hit the y-intercept at -1. So the y-intercept is -1, as you can see over here. So now we have all 3 equations for the 3 lines that are inside our rectangle. Now, let's see, what should we do now? Well, actually, we can find the intersection points right here. And this will definitely help with our problem, because if we get these intersection points, then we can actually find the areas of all 3 of these triangles, and then we'll pretty much be done afterwards. So let's find the intersection point to this right here. We'll call this point A, and this point B. So the intersection point, aka point A, is basically where the line y equals -1/2 x plus 1 and y equals 1/4 x plus 1/2 intersect. So let's set those two equations equal to each other. -1/2 x plus 1 equals 1/4 x plus 1/2. And now, after some manipulation, I'm just going to go a little bit quickly now, but you can see that x is equal to 2/3. Yeah, 2/3. You just have to put x to that side, put the 1/2 to this side, multiply a little, and you get x equals 2/3. And now, that's your x coordinate for A, but your y coordinate, just plug in 2/3 into one of these equations. Let's just plug it into this one. You get -1/2 times 2/3 plus 1, and you find out that that equals 2/3 as well, over here. So then we can say that A equals 2/3, 2/3. And now let's do the same thing for B. So for B, it's the intersection it's the intersection point of the lines y equals x minus 1 and y equals negative 1/2 x plus 1. So let's do that right now. We get negative 1/2 x plus 1 equals, sorry about that, x minus 1, x minus 1. And then after solving this equation, you get x equals 4/3. And then plugging that into one of these equations right here, you get y equals 1/3. 1/3. And so B is equal to 4/3, 1/3. Right here. 4/3, 1/3 is right here. And then 2/3, 2/3 is right here. So now all we have to do is find the areas of these three triangles. Now, how do we do that? Well, let's try to find the area of this triangle first. We know that, let's label the points over here. This is 0, 1/2. This is 0, 1, and then, so we're trying to label the vertices as points in the coordinate axis, and then A, as we found, is 2/3, 2/3. So, how do we find the area of a rectangle? Well, it's 1/2 times the base times the height. We can say that the base is this right here, so it's 1/2 times this base length right here, which is also 1/2, times the height over here, which in this case is just the x value. So it's basically 1/2 times 1/2, which is the base, and then the height, which is 2/3. And that is equal to 1/6. So this right here, let's see if I can write it, is equal to 1/6. Hopefully you can see that. And now let's do the same thing over here. Let's find the area of this triangle right here. Well, it's going to be 1/2, again, because a triangle's area is 1/2 base times height. 1/2 times the base, which is 1, and then times the height. And the height here is going to be the y value for B. Now we know that B is equal to 4/3, 1/3. And so the y value for B is 1/3. So it's going to be 1/2 times 1 times 1/3. Times 1/3, sorry. And then that is also equal to 1/6. So the area of this triangle is also 1/6. And now finally we have to find the area of this triangle. Now instead of trying to find the area of this triangle using 1/2 base times height, that would be kind of tricky, because if you might be able to find this length right here, but finding the height over here would be a little difficult, because you don't know where it kind of goes down, and you're going to have to break out even some trigonometry. It'll be really messy. Instead, let's do this. Let's find the area of this whole triangle right here, and then subtract this area and this area to get this area. So let's try to find this area, the area of this big triangle right here. Well, we know that it's 1/2 times base times height, aka 1/2 times 2 times 1, which is 1. So the area of this whole thing is 1. Let's write that over here. It's 1 minus, and then we have to subtract the area of this triangle and this triangle to get the area of this triangle. So let's find the area of this triangle. Well, that's 1/2 times 2, which is the base, times the height, which is 1/3. The reason it's 1/3 is because the coordinate for A is 2/3, 2/3. The y coordinate for A is 2/3. So that means, and this whole the whole y value of the rectangle is 1. So to get up to 1, you have to add 1/3. So that means there's a 1/3 distance for this height over here for this triangle. So it's going to be 1/2 times 2 times 1/3, aka 1/3. And now let's try to find the value of this triangle right here. So to find the value of this triangle, we can say it's 1/2 times this base, which is 1, times this height, which is 2/3, because the x coordinate for this b value right here is 4/3, and this whole x coordinate value for the rectangle is 2. So it gets to 4/3, and then you need to add 2/3 to get to the end over here, because 4/3 plus 2/3 equals 2. So therefore, it's going to be 1/2 times 1 times 2/3. So 1/2 times 1 times 2/3 is 1/3 again. 1/3 again. So that means 1/3 plus 1/3 is equal to the area of these two triangles right here. And when you add them up, you get 2/3, and when you subtract them from 1, you get 1/3. And that is the value of this final shade triangle right here. So now we are almost done. Let's add all the areas for all of the triangles. So we got this area right here, 1/3, plus this area right here, which is 1/6, and then plus this area right here, which is also 1/6. So 1/3 plus 1/6 plus 1/6. And then be careful because we actually have to divide this by 2. And the reason for that is because remember, this whole area over here of the rectangle is 2 times 1. And we have to find the fraction of the rectangle that's shaded. So we can't just add these 3 fractions up and call it a day. We actually have to divide by 2 because that will give us the actual fraction of the rectangle that is shaded. So you get 1/3 plus 1/6 plus 1/6. That is equal to, well, 1/6 plus 1/6 is 1/3. 1/3 plus 1/3 is 2/3. 2/3 divided by 2 is 2/6. And then 2/6 is equal to 1/3. So therefore, the fraction of the rectangle that is shaded in this rectangle right here is 1/3. And we're done.